a while ago, I posted a video where I used a magnet to show the difference in copper content or metal and materials used in various brands or off brands of tips, 900M, aka T18, ordinary, soldering tips for this type of heater. And I was a little bit inaccurate in one thing, is that I assumed that the Hakko tips would not be magnetic from stem to stern and only primarily at the tip end, where of course they are and should be plated with iron, because bare copper doesn't last very long when it's hit with molten solder and flux. But I did buy some, since then I bought some tips from Hakko directly, and interestingly enough, they are magnetic equally from stem to stern. I did somewhere online find a cutaway diagram of one of these from Hakko, which I can no longer locate, and I lost it in the download on my phone by accident, or the picture. But they do iron plate the entire tip from one end to the other, and then they put chrome from about this point onward to the back, because these solder won't stick to the chrome. Anyway, the other real big issue that I might have talked about last time, but didn't really get into then, is the size and fit, snug fit or lack thereof, of these types of tips. Now here's a Hakko tip. And you can see it's a little less than 4 millimeters, depending. I'm rotating the tip, and I'll try another bite at it. Kind of hard with the tapered tips on this unit to get a good bite per se, but it tends to, maybe kick out because they're tapered. But anyway, here's another one. This is also a genuine Hakko tip. These are bought from Hakko USA. So I know they're not clones. Okay, 3.88, 3.9, it's about right. Now here is a Schneider Harbor Freight iron with from a soldering station. They're 80 water with a fairly typical ceramic element. And I get just over 4 mil. Let's see if I can do it this way. And you can still see it. 4.1 to 4.2. I'm turning it. The rod's got a little bit of an oval to it, but it's around 4 mil or a little bit smaller, depending how and where I measure. But certainly a snug fit with tips that measure less than 4 millimeters. And as you can see, I'm going to hold the ceramic. As you can see, it's pretty snug. There isn't a lot of play. Most of the play you see like this is the actual ceramic element in the tube has some play to it. But if you do this, you'll see there's very little play. Here's the other Hakko factory tip, genuine tip, and you'll see very, very little play. Now, if I use the other Harbor Freight Schneider iron, this one's kind of unusual in that it has metal on the tip. It's a little fatter. I think it was about 3.95. Sorry. That can't be right. Let's try this. Can we get that under there? 3.95, yeah, something like that. Doing it off camera. 408, depends how loose. If I pull it off, it expands. But you can kind of see what we got going on here. So this one's a little fatter than the ceramic element. And if you put in particular a Hakko on there, Hakko, It's just like look, there's an air piston almost when I put it on, like it didn't want to go. And there's like no play in it. So nice, snug fit. I wonder who makes elements that are 50-watt elements that are like this. Might be worth getting some. Anyway, now let's show you what happens if I try something else. These are the tips that came with the Harbor Freight Schneider irons. Got several in there and a few over here. And they vary a lot, quite a lot. There were some that were just over 4 millimeter. I think it was these. Or just a little less, depending on how much of a bite I get in there. Okay, so pretty snug fit. I'm rotating the tip, and it's not changing much. Another Schneider tip. Okay, yeah, 4 mil, just under. Nice snug fit. The unfortunate thing with these, however, is that they're conical tips. Basically, they do include, let's see, yeah, see, depending how much of a bite I get on, it's a little under, a little over 4 mil. But at least one of the others was really sloppy. Another Schneider tip. This one's not too bad. This one's not too bad. I hope I grabbed the right ones. I don't know. It can be tough to tell. Schneider does brand them. Yeah. I think I had one that was like 4.15 or something. This one's obviously a little sloppier hole, I think, than the others. Anyway, you probably... Oh, wait a minute. No, that's right. Okay. Two of the tips they give you are ostensibly, by the way, chisel tips. I think they're, they're B style, is what they call them. I hate conical tips. I really prefer a chisel tip, but as chisels go, these are a little small unless you're doing really fine work. But they'll sort of do. I took a couple of them and ground them away, and you can kind of see a little bit of a coppery edge there, so there might be some copper content or copper alloy underneath there, if you can see the color. They just kind of suck because they don't give you a good range of chisel tips with those particular irons, which was one of the reasons I bought some more better ones in different sizes from Hakko. Okay, here's some from various sources. I think there's at least one AOYUE in here. That might be this. Does appear to be copper. And the fit was pretty good on this one. Yeah, just under 4 mil as I spin it. I have some different ones that some came from Ace Panda, from China or whatever, and I'm not sure about the others, but you'll see that they're not horribly bad, You can find some that are better, and they're definitely made of different materials. If you look at the finish, these are much duller color than the others. They do seem to be primarily copper. Okay, hang on, 4.15 maybe. Yeah, 4.13, 4.14. So getting a little sloppy. 4.15. And I've got some that are worse. Wait till I show you the last batch. Yeah, 4.1. Okay. So whatever you have for tips, or where you're ever getting them from, check their inside diameter and measure the heating element of your iron. 4.11112. Not horrible, usable, and they all seem to have some reasonable copper color content. Put these in here, and now these pieces of you-know-what excrement, how's that? about 4.5 millimeters, which is terrible. See? There's 4.4 something. 4.2. I don't remember where these were from, but they look to be from the same source. They got the same type of finish and all. 4.55. 4.5. So you will not get good heat transfer from any of these. Did I grind one or not? I didn't try grinding at these to see what they're made of. They are not really magnetic, so they're probably copper. If they're only magnetic at the tip. If they fit better, or if you happen to have an iron with, for some reason, an overly fat, oversized element, you might be all right. But, at 4.5 mil or pretty close to it, they're going to be a lousy fit. Here, actually, let's show you what one looks like when you put it on this. Terrible fit. Very sloppy, very loose. Yeah. I won't even bother with the fourth one. You'll get the picture. And if I do it on this, which is about 1/10 of a millimeter fatter on the heating element, a little snugger. Actually, this one is must be rough on the inside. Rough finish. Son of a gun. Look at that. Where'd that come from? Somebody at the factory, put a little sleeve in there. This was not me. I don't know where this came from, but they put a sleeve in there to fatten it up. Without it? Oh, my Lord. Let me see if any of these others have it. That's an interesting sleeve that if you could find these somewhere, you could maybe put inside your sloppy fitting elements, to see if they snug it up. But it's like they forgot it on these, even on the fatter 50-watt heating element. These are quite loose. I got one more. Yep. That would be why one of these measures a little snugger than the other. Okay. Do this. Sorry, I hope I'm not giving you guys vertigo. All right. Even with that sleeve in there, well, it's hard to reach all the way. 4.48. Same. 4.5. But the sleeve does seem to, you'll notice it won't fall on by itself. It does seem to grab a little bit. But it wants to come out with the bit, with the tip. So that's interesting. None of the others have it. If I do this and pull, they don't come. So maybe they forgot to put the sleeve. Or, they're all pretty sloppy by about the same amount. But That's interesting. See? It's kind of fun to do these unscripted. I didn't know what to expect anything like this. Anyway, so there you have it. Now there's one more possibility for using tips you may have that are a little sloppy and loose. I have not tried it, but I bought some anti-seize lubricant that's high temperature. This is Permatex 81343, and although I don't have the package, I looked it up. It's supposed to be good up to 870 centigrade and 1600 Fahrenheit degrees. So a small dab of this would probably cut down on the air gap between the tip and your heating element. Also prevent it from sticking on there, I presume. I don't expect it would dry up very much. But you'd have to try it. I have not, as of yet, tried it. Maybe that'll be another video. But anyway, that's what we've been up to here. Yeah. And there's more than one important thing in terms of material. The having copper content is better for heat distribution, and also the more mass the tip has. If you have a sloppy inner hole, that means the tip is going to be lighter compared to a tip the same size of the same material with a snugger hole. And the more mass you have, the better thermal transfer you get, and probably the more efficient your soldering operations will be. So until next time, just remember, size matters.